Complex numbers, de Moivre's theorem, type 2, prove trig identities. So in this type here, we're going to be asked to use de Moivre's theorem to show that cos 3 theta is equal to 4 cos cubed theta minus 3 cos theta. And sometimes we will also be asked to show that sine 3 theta equals 3 sine theta minus 4 sine cubed theta. But most of the time, it'll either be asked to show 1 or 2. So the key word here is that we have to use de Moivre's theorem. In other words, we can't just use compound angles and say cos theta plus 2 theta and then use cos of A plus B or sine of A plus B to show that the left-hand side equals the right-hand side. So we have to look for where do we begin, what's the hint that we have to use for de Moivre's theorem. So if we write down what is de Moivre's theorem first of all, well, we know from page 21 in our maths tables that if we have z is equal to or cos theta plus I sine theta, in other words, in polar form, then if I raise it to the power of n, then the modulus gets raised to the power of n and the angle gets multiplied by n. So that's our clue for this question here, that this power gets multiplied by the angle. So if we look at what it is we're trying to show, we can clearly see that we have to show that cos 3 theta or sine 3 theta is equal to these right-hand sides. So therefore that tells me that the coefficient of the angle is our hint. Is basically going to be n. So if I set up de Moivre's theorem, that's going to be our first step. So from our first step, we can see that if I have cos theta plus I sine theta raised to the power of 3, then that will give me this cos 3 theta that I'm looking for. And also, it gives me the sine 3 theta that I'm looking for. I don't need a modulus here because there's no number in front of the cos 3 theta or the sine 3 theta or outside the brackets or anything like that. So we would assume that our modulus is 1. So we're going to call that equation 1. So that's the first step here. The second step is that we're going to take this cos 3 theta and I sine 3 theta to the power of 3, and we're going to look at another way of writing that. So in other words, we're going to use binomial expansion to multiply out our brackets. To speed things up, you could multiply them out, obviously, by itself 3 times, but we're going to use our binomial expansion instead. So again, our binomial expansion. So if we're looking at page 20, I think I might have said page 21 a minute ago, I did. Sorry, that should be at page 20 there. Then we'll see our binomial and our de Moivre are on the same page, which is page 20 in our tables. So by expanding it, we're going to have n choose 0, so it's going to be 3 choose 0. In other words, that's my n. And then our x term and our y term, well, our x term cos theta is going to be raised to the power of n, so that's to the power of 3, times I sine theta to the power of 0. So again, lowest starts at highest power for the first term and 0 for the second term, and then they decrease by 1 as the other increases by 1 each time. So we have 3 choose 2, cos theta to the power of 1, I sine theta to the power of 2. That previous one should say 1, sorry. And then the last term there, 3 choose 3, cos theta to the power of 0, I sine theta to the power of 3. So again, you can see each of those terms, the lowest add to give you 3. So if we simplify that, that gives us cos theta, I sine theta to the power of 3 is equal to 3 choose 0, which is 1. Cos theta cubed is cos cubed theta. Anything to the power of 0 is 1. 3 choose 1 is 3. Cos theta to be squared is cos squared theta. I sine theta to the power of 1 is just I sine theta. 3 choose 2 is 3. Cos theta to the power of 1 does cos theta. And again, we have to be careful here. We're going to have I squared sine squared theta and then 3 choose 3 is 1, anything to the power of 0 is 1, and then again be careful, I sine theta to be cubed is I cubed sine cubed theta. Now we don't want this I squared and I cubed, so we have to remember that I squared is minus 1, which means that I cubed can be written as I squared times I, which is minus I then. So if we tidy up that line, then that gives us cos theta plus I sine theta cubed is equal to cos cubed theta plus 3I cos squared theta sine theta. So I'm just using I as a coefficient there. And then we're going to have minus 3 cos theta sine squared theta. And then minus I sine cubed theta. So this is the second way in which we can write cos theta plus I sine theta cubed. So we're now going to take those two equations and we're going to equate them because they both represent the same thing. So equating 1 and 2 for cos theta plus I sine theta cubed. And what that gives me then is cos 3 theta plus I sine 3 theta equals cos cubed theta plus 3I cos squared theta sine theta minus 3 cos theta sine squared theta minus I sine cubed theta. And now if we look, here's our cos 3 theta, and that's a real term. So if I look at the sine 3 theta, that has an I in front of it, so that's an imaginary part. So by looking at the right-hand side, we can underline all of the real, imaginary, and then what we can do is we can equate the left-hand side with the right-hand side for the real and the imaginary parts. So if we look at the real parts, well, that gives me cos 3 theta equals cos cubed theta minus 3 cos theta sine squared theta. But if we go back to the start of the question, that's not what I'm looking to show. I'm looking for 4 cos cubed theta minus 3 cos theta. So there's no signs in my answer, which means that I don't want this. So if I don't want the sine squared theta, I have to remember that on page 13 in my maths tables, our favourite identity, sine squared theta plus cos squared theta equals 1. So that means that I can write sine squared theta as 1 minus cos squared theta then. So that gives me cos 3 theta equals cos cubed theta minus 3 cos theta times 1 minus cos squared theta. And then all I need to do is multiply out my brackets there. And I get 3 cos theta times 1 and minus 3 cos theta times minus cos squared theta. So minus by minus is plus, and cos theta by cos squared theta gives me cos cubed theta. Now we can see that we have two terms that have a cos cubed theta in it. So if I add those together, that gives me cos 3 theta equals 4 cos cubed theta minus 3 cos theta. And that's exactly what we were looking to show. So if you pause the video and see, can you do the same for the imaginary parts? So of course we don't need to put in the i's. We're looking at the coefficients of the i's must be equal on the left and the right. And again, if I replace the cos squared theta this time with 1 minus sine squared theta, because there is no cos in what I was asked to show, then by multiplying out my brackets, I have 3 times sine theta and minus 3 sine cubed theta minus sine cubed theta. And that leaves me with exactly what I was looking to show, that sine 3 theta equals 3 sine theta minus 4 sine cubed theta.